Hello everyone, I hope you are doing great. In this tutorial video, I would like to talk about simulations of solar cell softwares that can help in your project. I hope you subscribe to my channel, share my channel to your friends, like my videos, and share your comments. Let's get started. Here I provide a good paper that summarizes the simulation solar cell softwares, and this paper is published on 2025 with the title of An Overview of Solar Cell Simulation Tools. Here you can see a table of simulation software that is summarized. The first is ADEPT. This is the software that is free of cost. Development of Fortran 77 that can be run on Windows, Mac, and Linux. The simulation is feature that you can simulate a crystalline silicon solar cell, thin film solar cell, CIGS, cadmium telluride, amorphous silicon, gallium arsenide, and tandem solar cell. Let's find this software. I just go to Google and let me copy this. I search ADEPT solar cell software. You can see the first link is a PV Lighthouse. This is a good software that educate simulation of solar cell, theory of solar cell, and semiconductor. Here you can see a link for this software that from is nanohub.org. Also, I must tell you I use a VPN changer or IP changer. Here you can see a launch tool that guide you in a new link. You must fill the form and specify your identification, your scholar research, your scientific fields, your education, and some scientific information. The second is AMS1D that I work with this software and I publish paper developed by Fonash et al. That is free. You can run it on any version of Windows. Previous Windows, for example, XP Windows. For Windows 10 and 11 or 8, you must use a Windows emulator or VMware workstation software to use Windows XP simultaneously to run and install this software, because this is not run on newest version of Windows. Crystalline silicon, thin film solar cell, amorphous silicon, CIGS, perovskite solar cell, we can simulate. Let's search the software. You can see some sites that talk about this software, but there is no link for download. In the last, as I remember, they have a good site with the data of material, but now I can't see any link. You can email to me or message on WhatsApp to me. I will send this software for you if you need it. But this software must be just installed on Windows XP. You remember that. The other is AFORS-HET. AFORS-HET, it is the software that is free and developed by Fortran. I work with this software and this is good software. You can run on any Windows. The simulation feature is amorphous silicon, crystalline silicon, and tandem perovskite, tandem solar cell, and also you can use in perovskite solar cell also. This is a 1D software, and you can search on Google. And you can find this link of software. If you didn't find, you can just find papers and email to corresponding authors and ask them for the version of this software. Here you can request download by inserting your email and capturing okay, you must modify that you are not robot and just give them a invitation email link. Okay, the other is ASA, that is not free of charge. It's based on Fortran. You can run on the oldest version of Windows and Linux or Windows Vista. Amorphous silicon, microcrystalline silicon, perovskite solar cell, tandem solar cell. You can use this software, ASA. Let me search. You can see different. You can see ASA. This is not free. It's 2,100 euro per year, and then you can see 20% as educational discount. Okay, the next one is Aspin. This is free of cost and you can run on Linux, Mac OS and FreeBSD. Amorphous silicon, CIGS, PI and heterojunction solar cell. You can use Aspin. Just let me search. چند گذشت؟ Okay. And you can find these links. Maybe this is Aspen, and as you can see, it's related to the large scale solar cell, and you can simulate the large scale and modular solar cell. The next is OGHAM Nano, that is free of cost. You can run on Windows. Polymer, crystalline silicon, amorphous silicon, perovskite solar cell, and CIGS thin film solar cell. You can use OGHAM Nano or maybe OGMA Nano. This is OGMA Nano. It's you can download it. It is free, and then you can see there are many videos about that. And this is 55 megabyte for downloading, and it is so easy for download. Okay. PC 1D, I work with the software. This is a good software, but it is 1D and it is free of cost. You can run on Windows 95, and I tried its work on Windows, newest version of Windows. Crystalline silicon, indium gallium nitride solar cell, and maybe other type of solar cell. You can try it, but let me search. You can find in PV Education and PV Lighthouse just by going to website link and filling the form to request the version of this software. Okay. The next is PESCIM. that is free of cost. You can run on Windows and Mac. That is for dye solar cell, quantum dot, sensitized solar cell, and perovskite solar cell. Let me search this. PESCIM solar cell software. You can see this link, just an short abstract about this software, and there is no link for downloading. Maybe you can find some paper and request to the corresponding author to send the software link for downloading. Okay, this is the SCAPS one, as I talked about it in these two videos. You can see and these two videos. The next is SETFOS. SETFOS is the not free, and it's need the charge. Based on Java, you can run on Windows and Mac, organic solar cell, and every type of solar cell. I just worked with the free version of that. That limitation on some features, you can request it. This is a good software. Let me find this software. This is SETFOS, and you can find some demo on solar cell simulation about that. The basic site is Fluxsim, and you can see the feature of this software. That maybe it's for 2D. The next is Silvaco Atlas. It is not free, and you can run on Windows and Mac for organic solar cell, CZTS, tandem solar cell, and photodetector. The Silvaco, it needs to writing a code and a script, and it is maybe similar to Comsol, but the Comsol it's the god, and it's better than all of them. And let me continue. Silvaco also, you must pay the charge for that. You can search on Google. Excuse me. Okay. You can go to Silvaco site and request your software. Silvaco maybe include some additional software, maybe using Atlas, Antenna, or I don't know, some different platform of that. That is applicable for solar cell, LED, photodetector, photodiode, and other semiconductor devices and optoelectronic devices. Okay. The next is TCAD. TCAD also is not free and is based on C, C++, and Fortran. You can run on Windows, CMOS, power, memory, image sensor, solar cell, and RF devices. Just let me search about it. TCAD. This is Synopsys Centratus TCAD. It is the software that you can simulate every type of solar cell. But these are not free. Okay, and you can just request for downloading and pay the charge for using in 1 month or in 1 year. It's different cost. And in table 2, they brief a description of newly developed solar cell simulation For example, Kubu GUI, that inventor is Ediollah et al., Ediols et al., and ISFH. This tool is a script collection based on MATLAB and Comsol that can simulate crystalline silicon, concentrator, thin film solar cell, and organic and perovskite solar cell. With the Comsol multiphysics and MATLAB, you can build some software. I built a software, solar cell software, that I will introduce in my new video. And these are a good platform to develop your software in any field, for example, solar cell. And I make a good video about building software with the Comsol in future. And just let me search this software. It's the platform based on Comsol, Kubu GUI. We can see that. Okay, we can see a link, ISFHD, to download this software, or you can request the download link, and maybe you can find it just by sending your email address. And this is a German site. You can translate it to English to see what the requirements are needed for this software. Maybe you can go to software in this site and find that software. Maybe on electricity tool. You must some search on it. You can see different version, and you must fill the form to send the download link for you. The next is eDNA, that is developed by Macintosh and Australian National University. This tool analyzes the recombination and connection associated with phosphorus or boron emitter, can determine the emitter saturation current and Fermi-Dirac statistics, and model works only for crystalline silicon. This is some limitation, many limitation, because just you can simulate crystalline silicon. eDNA, we can just search it, and just from PV Lighthouse, as we saw, the PV Lighthouse has many links of the software that help us. Maybe we can go to simulation and see the different software or simulation programs, and then it is very good website. Let me show you. You can see for optics, solar cells, semiconductor physics, circuits, PV system, and cost. You can find them. And here you can see a simulator, online simulator, and it is interesting. Okay, PC3S that developed on MS Excel to calculate surface parameters specific to silicon crystalline, 3D surface texture, doping profile, surface recombination, velocity, and you know these are so limited for our works because they don't give us the IV calculation, the other important parameters like band structure or recombination in any surface in every position of a solar cell. And you can find here and request it with this email. And there is many versions, and you can also see a PC1D here. Nice. The next is Quokka, that is developed by Androsfell, Australian National University. This simulation tool was developed on MATLAB to simplify charge carrier transport that results in model that is computationally inexpensive without a loss of generality for silicon solar cell only. Just it's work for silicon solar cell, but you can try other solar cell types. It is arbitrary. You can see there is a site for that. Quokka 3, a key feature. You can see the feature of this software, and you can download it maybe freely. Free academic, full academic. Yeah, you can see the full academic is not free, and you must pay the charge. Okay, QS cell. Let me find this. In PV Lighthouse you can see, and also it has a good site and link for downloading. Maybe this software is also for large scale, and you can find it. Okay, let me try MSC1D, and this tool is developed for multijunction solar cell that is capable for modeling and simulation of 3IV based tandem and MJSC that cannot simulate the performance of matrix of single junction. Just we can search. You can see a paper, and we must just request from the corresponding author emails. The next is OPV lab. OPV lab, okay. In PV Lighthouse, we can see OPV lab, the link, and we can request by filling the form with institutional email or with your Gmail. This tool simulates the IV characteristic for organic solar cell with bilayer or planar heterojunction configuration with flux at DA interface, carrier generation, and biomolecular recombination. That does not have any defect model, and it has some limitation. SARAH. SARA employs the diffusion resistant concept and the superposition principle to simulate the prevalent IBC cell design featuring line P plus and N plus diffusions and front surface field. That not can calculate the IV curves. We can search. Maybe for some project it is okay. Just okay. Sarah IBC. Maybe there is no search results. Okay, in PV Lighthouse we can see the software information, and here we can see maybe IV curve for this software. And this is a two-dimensional model for integrated back contact solar cell. And you can see a paper that we can email to the corresponding author and request for this software. Okay, the next is Solcore, Alvarez et al. From Imperial College of London. This tool provides a multi-scale Python-based library for modeling solar cell, 3IV, silicon, germanium, and tin, and semiconductor alloy materials, but cannot calculate multijunction characteristics under radiative coupling and illumination condition. We can search it. Here we can see this website solcore.solar, that we can request for code, documents, and example. Okay, we can see an example here: quantum solver, light sources, optical methods. And in GitHub we can see the source code of this software. Just I keep this GitHub, I want to talk about it at the end. We can see the Solis. It is a Sidi Hamadi, University of Lorraine. This tool implements drift diffusion transport model, various recombinations, supports anode and cathode parameters, and handles spontaneous and piezoelectric polarization, allowing flexibility in simulating heterostructure solar cells, but cannot simulate tandem solar cell. Okay, it's done. The simulation software, they investigated were these softwares, but maybe you search in Google, find another software also, and I want to show you. Here you can see Solis Technical Global, and you can download it. It's okay. There are many good websites, for example, GitHub, ResearchGate, Google Scholar, and a PV Lighthouse, PV Education, and you can just find the software by searching softwares. Here in product in GitHub I can search solar cell, and you can find some good sources, good data, and code, simulation codes. You can see all of them. There are many suggestions here, and you can just use the language you want, maybe MATLAB, C++, Python, Java, or let me search IV curves. and you can see a different result. For example, perovskite solar cell. I search perovskite solar cell, and you can see this code, this current density versus time, charge stored, current density versus time, and you can see the free codes with the examples. And the M is a MATLAB file, and PNG is the picture of the results. Okay, and other example, you can see the description, and here CTS solar panel, maybe electronic devices, some circuits. Okay, and also about Comsol, you know that Comsol is the best software, as I know, for simulation of solar cell and every type of optoelectronic devices. The Comsol is user-friendly. You can just adding equation by just few clicks, and also coupled many physics together and simulating every type of optoelectronic devices without any limitations. Okay, I hope you enjoyed this video. Please subscribe to my channel, like this video and all of my videos, and share my channel to your friends, and take care. Give your comments and let me know your opinion about my channel and my videos. Recently I uploaded many videos about life hacks, handyman hacks. I think the diversity of channel helps me to get more views and more subscribers. And maybe in future I'm willing to make some good videos about simulation and connecting the real life with the simulation tools. And don't worry about the content of my videos. I will amaze you. Have a good time. Take care. Goodbye.